Welcome to our Signal Media Executive Interview Series. I'm Kimberly Underwood, Director of Digital News Media at AFCEA International Signal Magazine. Welcome to our episode today entitled Innovating at the Edge, Unlocking Resilient, Mobile, Multi-Orbit Communications, which is sponsored by Tampa Microwave, which is a Thales company. Today, I'm speaking with Aaron Brosnan, President of Tampa Microwave, who will talk about next-generation satellite communication and the company's strategic investments in mobile, expeditionary, and modular command post communication solutions. Nice to meet you, Aaron. Thanks for joining me today.
Hi, Kim. Good to meet you too, and glad to join.
Great. I'm so happy to kind of delve into Tampa Microwave and kind of how you all are really enabling, true multi-band, multi-orbit connectivity across commercial and military satellite networks. Can you talk about that a little bit? And then why does that matter to the warfighter?
Yeah, so maybe I can take a step back. Tampa Microwave has been supporting military satellite communications for, going back to the mid to late 80s, 1980s. So, different technology then and a different ecosystem, different market. Back then, everything was geosynchronous orbit. So imagine a satellite that's fixed in the sky and you pointed an antenna at it and then you could walk away. You didn't have to track anything. That was a monolithic architecture. But it was perfectly suitable for, the way we fought missions or conducted missions or fought battles back in the day. Fast forward to today, where there's a higher demand on access to data. It's always more data is more important. It's also a higher requirement on resilience, so that you always have access to that data. And so there's also the advent of non-geosynchronous orbit satellites, really driven by the commercial industry. And for the same reasons, it was about how can I get more coverage around the globe? How can I get more data to the users? And how can I make sure that that's a reliable mechanism for getting access to that data? You can imagine that the military has those same requirements. They need to be able to deploy around the globe. They need to be able to access resilient, high throughput data anywhere that they deploy. And so the whole industry has changed. And so has Tampa Microwave. So for us to be able to address that new need, now we have a whole new range of products, both partly through an acquisition, but also through internal investments, organic internal investments, to address what we call, I think it's a misnomer, but it's called multi-orbit satellite communications. And I'll come on to why I think that's a bit of a misnomer. But anyway, that's where we're at, and we're excited about the future of this market and this space.
Right, sure. And especially in this day and age, companies really need to be tuned into their end user. Can you talk about that a bit and kind of what customer requirements are driving your investments?
Sure. Okay. So this is maybe the good opportunity to talk about, multi-orbit versus what I call multi-network. And if you think about your cell phone today, you turn it on, you might roam, around locations geographically. You might actually take it home or take it to the office, and it's just automatically connecting to whatever network's available to it, right? Whether it's Wi-Fi, Bluetooth, or cellular. The idea with the future satellite communications terminal is that you can get on any network. What defines a network? It's a whole bunch of things, including the orbit that the satellite operates in. So hence multi-orbit. So, and again, I mentioned in the old days, geosynchronous orbits. Now a lot of the importance in military communications is non-geosynchronous. For a couple of reasons. One is because, non-geosynchronous effectively means, you're running on an orbit around the Earth that's much closer to the Earth. So you can imagine that's important because it gives you much, much lower latency in terms of the round trip over the satellite and then back down to the Earth. So that's important. You also have, more state-of-the-art satellite constellations and payloads that are running more complex waveforms that are much more broadband, so you can get much higher throughput data. So that's important as well too. And then just the fact that you have multiple satellites in multiple orbits gives you a lot of what we call path diversity. So the ability to be able to connect to any satellite in any orbit in any region dynamically. And you can imagine if you get jammed on one satellite, you can quickly move to a different satellite and maintain your communications. So that's path diversity, and that's important. So back to orbits and networks. So what else defines a network? We mentioned orbits. We can also talk about the band that it operates in, right? So you can imagine, a very important constellation these days for the military is Starshield, SpaceX. That operates at Ku band. If you look at Amazon Kuiper, that operates at Ka band. And if you look at OneWeb, that's operating at Ku. If you look at a lot of the legacy WGS geo satellites, those are X band. So there are different spectrums or frequencies within the RF spectrum. So again, you need a terminal that can maneuver both across orbits, but also across bands, spectrum. And then I would say the last thing is, the modulation types, right? So every network has kind of a unique way that it scrambles the traffic to get it over the RF. Modulates it and demodulates it. So you need to be able to, adjust your modulation schemes depending on the network that you're riding on. And that gets pretty complicated because, like I said, a lot of those modulation schemes are proprietary to the network. So then you have to think about, okay, how can I somehow virtualize those waveforms so that I can access them dynamically on the fly? And then so there's a whole move towards waveform virtualization in terms of the modem architectures and the future terminal architectures. So multi-network is really what we're talking about. Multi-orbit is just one piece of that.
Right, sure. And as far as end users, whether it's soldiers in tactical units or those at, command posts, what can they expect from Tampa Microwave's next generation of SATCOM terminals?
Absolutely. Good question, Kim. First of all, the new peer threat is demanding a much more agile fighting force. So, you can imagine in the past at a division level, fighting force, you could take days to weeks to set up a command post and days or weeks to, tear it down to move it. That's just unacceptable in a modern day peer threat environment. We need to be a lot more agile, which means smaller, lighter, more maneuverable. So I think one of the things about Tampa Microwave is that we started with special forces. So everything for us has always been about expeditionary warfare. So we've always been, as small and light as we could possibly make it. Now what we see is, okay, let's now migrate to the new multi-network constellations, but do that in a way that we maintain that level of, really small, light, maneuverable, small package solutions. So that's an important aspect of the future requirements that are coming. I already talked about the fact that the idea of the multi-network gives the soldier on the ground a lot more resilience in his ability to maintain his connectivity over the satellite. Jam resistance, whether it's being blocked by an adversary or whether there's just a lot of congestion in the spectrum, he has the ability to move quickly between satellites so that he can stay on the network. The last thing I would say is just the new modulation schemes in the modulation and demodulation technologies are creating much higher throughput in terms of bandwidth. So, that also gets really exciting when you talk about, the things that a soldier on the ground is going to be wanting to do in the future architecture. It's a lot more about, sharing a common operational picture, understanding certain intelligence reports, intelligence, surveillance, reconnaissance type reports where they can see, videos of, locations of enemies and see that in real time. So just a lot more access to critical information because of the broadband connectivity piece of the future architecture. Certainly that multi-network capability for resilience and that low latency that we talked about in lower Earth orbits and smaller SWaP is all really, really important to the future warfighter.
Right, sure. And Aaron, you talked about kind of being able to supply path diversity and, terminals operating across different spectrum bands. Can you kind of delve into the terminals a little bit more, and how do your
Sure,
terminals kind of dynamically switch, between
sure.
GEO and MEO, in real time?
Sure. So the first thing is that, advances in technologies like electronically steered arrays, antenna designs have enabled the ability to be able to steer beams, for example, to track a satellite and also to switch between satellites in a matter of milliseconds, hundreds of milliseconds. So almost imperceptible to the user. So, and that's critical, right? Because you need to be able to do that without dropping, traffic, if you will, or connectivity. So things like electronically steered arrays and passive arrays have enabled that capability. I did mention earlier that small and light is really important. Well, it's a countering sort of demand on the terminal design. On the one hand, smaller and lighter is what the users need. But on the other hand, as I mentioned, they need higher throughput. And sometimes that means a bigger antenna. So you're trying to find the right balance. I think what Tampa Microwave is being able to achieve, just because of our expertise in doing things in very small package, high performance packages. We're really good at mechanical design, but we're also really good at very efficient RF design and cooling technology, because the more you pack into a smaller package, but try to maintain at least, if not better, performance, then you got to worry about how you keep that cool, right? Because it could heat up very quickly. So we're really good at how we manage the thermal, capability of the terminal design. And then lastly, I kind of touched on it earlier, but the other enabling technology is the modems, in the modulation schemes that they can adopt for that higher throughput, but also now moving to this virtualized architecture so that you can move between waveforms and modulation types quickly through a virtual architecture. Those are some of the new things that are coming.
Right, sure. And in that vein, kind of looking to the future, can you talk about your SATCOM roadmap and kind of how
Yeah,
you think it aligns, or how you're positioning it to align to the military strategy for resilient C3, command
yeah.
control communications?
Yeah, sure. So if you imagine this future architecture that's all different orbits, whether it's LEO, MEO, GEO, or HEO, it's all different bands. It's got these virtualized modem architectures. All of our focus at the moment is towards that future architecture. And I mentioned at the start that one way that we get there was through strategic acquisitions. And recently, I'm talking about as early as I think it was the spring of last year, we finished an acquisition. Thales finished an acquisition of GetSat out of Rehovot, Israel. A world leader in my mind, and I'm not just saying that because I'm biased, because they're part of Thales now, but really honestly, a world leader in electronically steered array on the move SATCOM terminal design. Really, really capable designs, very high performing, lead the industry in size, weight, and power. And really, really capable of getting on a myriad of different networks, giving the soldier on the ground lots of options, whether it's Starshield or Kuiper or OneWeb or Intelsat Flex or SES mPower. They're already certified on all those networks. So when a soldier takes delivery of a sling blade terminal from GetSat, they're actually getting access to all those networks dynamically. So that was critical because that gave us the ability to address those future requirements immediately today. Of course, GetSat continues to invest, but so does Tampa Microwave as two sister companies within the Thales portfolio of companies. So from a GetSat point of view, we're also investing heavily in ESA technology and multi-orbit terminal technology for on-the-move SATCOM. And one of the things that we're really excited about is a new product that's in development that we call Radar Terra. And what it's meant to be is to complement the GetSat portfolio, which is really geared for very high performance on the move vehicle-based SATCOM. The Radar Terra is really focused at what Tampa does really well, which is very small package, expeditionary, man-portable SATCOM. So our Radar Terra is really targeting that ability for a soldier to be able to basically package up their terminal into a backpack, for example, maybe an airborne unit that has to jump out of an aircraft. They can do that carrying the terminal in their backpack. Once they hit the ground, they can set it up in a matter of minutes. They can carry a battery pack with them. So it's, so high performing in terms of power consumption that it can actually run off batteries instead of AC wall outlet, for example, or vehicle power. So a very small package, very high performing, low power consumption. And then what really excites me is it'll be one of the first terminals on the market that can cover multiple bands. And so we talked about at the front of the conversation, the difference between multi-orbit and multi-network. Multi-network requires multi-orbit, but it also requires multi-band. And so our Radar Terra is going to be both Ku band and Ka band capable simultaneously, and even being able to track, for example, an Amazon Kuiper satellite as well as a SpaceX Starshield satellite. That's really critical because that just gives the user on the ground much more flexibility and resilience for his connectivity.
Right, sure. That's all getting so very sophisticated. Can you talk also about modularity and kind
Sure.
of field upgradability and kind of the
Yeah,
role you see those playing in, sustained SATCOM investments for the future?
absolutely. I think one of the things that's made Tampa Microwave famous, I'll say, in the SATCOM market for the last few decades is our modular design. That's something that we is really a forte of our engineering group here is being able to design things in a modular fashion. What does that really mean? Well, what that means in user terms is, for example, with our SOCOM customer, I can give them a terminal that a modularly designed terminal. Let's say it's a 65 centimeter antenna running on Ku band, supporting an iDirect modem. So again, back to the multi-network approach. I can take that same terminal in a matter of minutes in the field without any special tools or any special training and convert it into a 1.3 meter antenna running on X band on a Comtech network. And again, in a matter of minutes. So that gives the user lots of flexibility. One of the other things that we've done here very recently is taken that, leveraging that same, approach to modularity. And we've developed what we call a MEO upgrade kit. And really what it is a multi-orbit upgrade kit. And what that means is the user in the field, and we have some 4,000 terminals that have already been fielded to the DoD and some of our coalition partners. They don't throw away that investment. What they do is they buy an upgrade kit from us. And because of the modular design, they can literally take their existing geo-only terminal and convert it into a multi-orbit terminal by the inclusion of a tracking positioner so that it can actually track a moving satellite, like a non-geosynchronous orbit satellite, and a new modem. And when they do that, now their geo-only terminal can also run, for example, on an SES MEO mPOWER satellite, and it can track it and it can hand over to the new satellite and that sort of thing. We've also proven out that same tracking capability for HEO, in this case, the ASBM network in Norway, that was basically architected by Inmarsat, now Viasat. So again, the modular nature of our terminals allows them to upgrade without special tools. They can do that in the field and so on. Of course, with our new ESA designs for on-the-move satellite communications like Radar Terra, the approach there is very, very modular as well too. So the ability to be able to adapt the terminal, for example, for special purpose waveforms through the ability to extract and install new modems, the possibility potentially to break down the terminal into component parts so that it can be packed away much more easily from a man-packable point of view. So again, back to the modularity, that's also critical when we talk, especially when we talk about expeditionary communications.
Right, and those are all my questions, Aaron. Anything else you wanted to highlight?
Well, I think we covered it all. I would just say, on the one hand, what's going on in the satellite communication space, I would call revolutionary. You have to give credit to Elon Musk and SpaceX for what they've achieved with Starlink and Starshield. A lot of other companies coming along, as I mentioned, SES, Empower, Amazon Kuiper, and others. As a terminal provider, our whole goal is to make sure that we can deliver the warfighter terminals that can leverage all those networks. And so it's all about working with some of those network partners to make sure that we can support their waveforms, we can get on their constellations, we can go through their certification process to make sure that we qualify, to get on their networks. And it's exciting times because for us, it's embracing all new technology, creating all new, partnerships with some pretty high tech and, very advanced partners, market partners. And it's just, helping us migrate into a whole new direction that really is exciting because for us, at the end of the day, it's all about supporting the warfighter. Clearly, the new constellations, the new services that they provide, the networks they provide, are going to dramatically, improve the warfighter's ability to conduct their missions, and we love to be part of that. So that's what's really exciting for us at Tampa Microwave.
Right, absolutely, and I would definitely say that sounds revolutionary and impressive. So it's very cool to hear about how you're shaping up in the market as this adroit terminal provider.
Mm-hmm.
Well, thank you, Aaron, for walking us through how Tampa Microwave is addressing next-gen SATCOM capabilities.
Thank you,
Appreciate
Kim,
it.
and thank you for the questions. All good stuff. Appreciate the conversation.
Absolutely. And for more information about Tampa Microwave, please visit their website, tampamicrowave.com. And thank you for listening to this executive video.